Welcome to our third lecture on electrical circuit theory. In this lecture, in continuation to my earlier lecture, today we will discuss about signals. Now, what what is a signal? Signal is that anything that carries an information. Okay. Now, a signal is a time varying quantity. We, the electrical engineers, will understand the voltage or current as a signal. Today, we will discuss about some standard signals. Now, mathematical operations on those signals will give rise to a variety of signals. Now, as a standard signal, let us first start with the step signal or step function. Okay, now step signal, the utility of the step signal is the switching operation can be described by one step signal. Now, what a step signal is? The definition of a unit step signal is UT, or in some books you will find this as U minus 1t. The definition of UT or U minus 1t is this is equal to 0 when t less than 0, and this is equal to 1 when t greater than equal to 1. T greater than equal to 0. Now, if we plot the ut, we will get this is ut. Now, this looks like a step. Now, this looks like a step. Now, the value of this step is 1. So, we call it unit step signal. Okay. Now, the quantity in the first parenthesis is called the argument. The quantity in the first parenthesis describes the argument. Now, the value of the function or magnitude of the function is equal to 0 when this argument less than 0 and this value equal to 1 when the argument is greater than equal to 0. Now, follow this logic. Now, let us try to plot a separate function. The function is, say, u t minus 3. So, the value of u t minus 3 is equal to 0 when the argument, that is t minus 3 less than equal to 0, that is t less than equal to 3, and this is equal to 1 when the argument is greater than equal to 0, that is t minus 3 greater than equal to 0 or t greater than equal to 3. So, the function looks like this one. This is u t minus 3. This is the time axis. Now, before t equal to 3, the function value is 0, and from t equal to 3 and onward, this value is equal to 1. Okay. Now let us try to plot another function. Say one function is there, u 3 minus t. Now the value of u3 minus t equal to 0 when the argument, that is 3 minus t less than equal to 0, or t 3 minus t less than 0, or minus t less than minus 3, or t 3 minus t less than 0, minus t less than minus 3, or t greater than 3, and this is equal to 1 when 3 minus t greater than equal to 0, or t less than equal to 3. So the function looks like this one. The function value is equal to 1 when t less than equal to 3, and the function value is greater than when the function value is equal to 0 when t greater than 3. Okay, so this is the plot of u3 minus t. Now previously I mentioned that the switching function can be described by one step function. Now let us find how we can describe. Now let us check how the switching function can be described by a step function. Say one voltage source of constant voltage 5 volt is connected with one resistance R through this switch. This switch is closed at t equal to 0. So what is the voltage across R? VR equal to 0 when t less than 0, and VR equal to 5 when t greater than equal to 0. So we can write that VR equal to 5 ut. Okay. Now say the voltage is V here. So VR equal to what? VR equal to 0 when t less than 0. VR equal to V when t greater than equal to 0. The switch is closed at t equal to 0. So we can write that VR equal to V ut. This product is equal to 0 when ut equal to 0, or when t less than 0. The product is equal to V when ut equal to 1, or t greater than equal to 0. Okay. So the switching function can be described by one unit step function. Now say we want to make this function, this one. So the definition of this function is ft equal to 1 only when in this interval t from t equal to 0 to t equal to 1. So we can write this as this one, this one plus this one. Okay, now this is another function which starts from t equal to 1. So this value is minus 1, this value is plus 1. So after t equal to 1, this is plus 1 and this is minus 1. So after t equal to 1, this is equal to this, the sum of these two is equal to 0. So we can write that if t equal to what? If t equal to ut minus ut minus 1. Okay. Now let us try to construct another function by this step function. Try to construct this function by step function. This one. This is at t equal to 1, this is at t equal to 2, and this is t equal to 3. This is say 1, this is say 3, this is say 5. So we can write this as this is equal to this one plus after t equal to 1 there is a step of another step of 2. 3 minus 1 equal to 2. So after t equal to 1, this is another function which adds 2 with 1. Now after 2, one more 2 will be added with these 2. So after 2, we have to add another 2. So after 2, the function value will be, sorry, this is 2. After 2, after t equal to 2, the function value will be 1 plus 2 plus 2, that is 5. Now after t equal to 3, nothing is there. So after t equal to 3, 5 must be subtracted from these 3, from this sum. So this is equal to from t equal to 3. So we can write ft equal to sum total of these functions. This is f1t, this is say f2t, this is say f3t, and this is say f4t. So we can conclude that ft equal to what? Ft equal to f1t plus f2t plus f3t plus f4t. Now this is equal to ut. Now this is equal to 2ut minus 1. F3 equal to what? This is equal to 2ut minus 2. And F4 equal to what? F4 equal to minus 5. The magnitude is minus 5 here. Minus 5 ut minus 3. Okay. Now we can synthesize this. We can synthesize these functions as a sum total of some functions. Now we forgot to mention that this type of function is called a get function or pulse function. This is called a get function or a pulse function. Okay. Now let us proceed to another functions. One such function is a straight line function. One another important function is straight line function. Now we all know that the equation of a standard straight line is what? Y equal to mx plus c. Now m equal to what? M equal to slope or gradient of that straight line. And c equal to what? C equal to the y-intercept. Now let us take one example. This is y-axis, this is x-axis. Now say this is the straight line. Now this straight line cuts the y-axis at 0.6 point and cuts the x-axis at -3, 0 point. So what is the slope of this straight line? The slope of this straight line equal to this tan theta. Now tan theta equal to what? The magnitude of tan theta equal to here 6/3 equal to 2, and y-intercept, this is equal to m, and y-intercept c equal to what? C equal to 6 unit. So the equation of this straight line equal to y equal to 2x plus 6. So we can write it as 2 into x plus 3. So we can modify the generalized equation of a straight line as this one: y equal to the gradient into x minus the point where the straight line crosses the x-axis. Here the point at which the straight line cuts the x-axis is -3. So we can write the equation of the straight line directly as y equal to the gradient equal to 2 into x minus what? X minus -3. So y equal to 2 into x plus 3. So from now onward we will follow this notation directly. Now in the electrical engineering, one straight line function is called a ramp function. Now let us look what a ramp function is. This is, we are going to discuss on a ramp function or ramp signal. Now all the functions are the function of t only, not x. So we will discuss about the function, the graph of the function with respect to t. Okay, now one unit ramp function is defined as RT, or in many books this is written as u minus 2t. This is equal to t when t greater than equal to 0, and this is equal to 0 when t less than 0. This is called unit ramp function because the gradient is 1 here. The gradient is 1 here, and this passes through the origin. Okay. Now let us carry on some mathematical operations on the ramp function u minus 2t. Now say 2t plus 3t, this is equal to what? This is equal to 5t. Okay, now so u minus 2t, we can write u minus 2t as t into ut or u minus 1t. Okay, now 2t plus 3t equal to, we all know that this is equal to 5t. So the gradients can be added. Now say we want to add two straight line function. This is one with slope m1. Okay, this is up to t equal to a, say this one, and there is another function with slope m2, slope equal to m2, slope of the straight line is equal to m2. So if we add these two, the sum will be like this one. Now up to t equal to a, this is equal to say f1t, this is equal to say f2t, and f1t plus f2t equal to say ft. Now up to t equal to a, the slope of the resultant straight line, the resultant function is the slope equal to here m1, and after t equal to a, the slope will be m1 plus m2, m1 plus m2. Okay, now we can express this f1 as what? m1t ut, and we can express this as f2 equal to m2 into t minus a u t minus a. Okay, now we want to express this function. This one. Here the slope equal to say m, and here what is the slope? The slope here is equal to 0. This is parallel to the t-axis. So slope equal to 0. So this can be expressed as the sum total of two functions. One starts with the origin with slope m, and another starts at t equal to a, and the slope equal to what? This slope equal to minus m. Okay, this is from t equal to a. This is say f2t, and this is f1t. So we can express ft as the sum total of these two. So ft equal to f1t plus f2t. So this is equal to what? mt ut, and this is, we can express this as minus m t minus a u t minus a. Okay, the t minus a must be multiplied with this one, otherwise this is a straight line. This straight line can be expressed as m t minus a, but this can be expressed as m t minus a u t minus a, because this u t minus a equal to 0 when t less than a. So this starts from t equal to a. Okay, now a sawtooth wave with the help of the ramp function. Let us express a sawtooth wave with the help of the ramp function. The sawtooth wave looks like this one. Okay, now this can be expressed as a sum total of these three, this one plus this one, and if we add these two, we will get, if we add only these two, we will get what? We will get this one. In the previous example, we saw that if we add these two, we will get this one. So in order to get this one, we have to add another function, which is this one. Okay, now say this is equal to k and this is equal to, say, t equal to t. So we can write this as, this is a slope equal to what? K by t, and this should be slope equal to minus k by t, and we have to add another step function with this value minus k from t equal to capital T. So the sawtooth wave can be expressed as ft equal to k by t into t ut minus k by t t minus t, because this starts from t equal to t, u t minus t, and the third function is minus k u t minus t. Okay, now let us express another triangular function. With the help of this ramp function, or if required, the step function. The triangular wave or triangular function looks like this one, this and this. Okay, say this is equal to t, this is equal to 2t, and the magnitude, the maximum value or the amplitude is equal to k. So for this portion, the slope equal to what? K by t, and for this portion, the slope equal to what? The slope equal to minus k by t. So there is a change of slope. The change is equal to what? The change of slope here minus 2k by t, and there is another change of slope. Here the slope is equal to 0. So here the change of slope equal to k by t, only k by t. So we can write this triangular wave as this one. The triangular wave can be expressed as ft equal to what? Ft equal to k by t into t u t minus 2k by t into t minus t u t minus t. Okay, then we have to add another component, that is k by t, the change of slope, the change. Okay, now we have to add another function for this change. The slope changes from minus k by t to 0. So we have to add another slope, another straight line with slope k by t. So k by t 2 minus t u t minus 2t. Okay, now let us proceed for another important function, which is called the parabolic function. Now the definition of a parabolic function is first of all, the parabolic function can be expressed as u minus 3t. This is equal to 0 when t less than 0, and this is equal to t square by 2 when t greater than equal to 0. Okay, now the waveform of a parabolic function is therefore can be expressed as this one, this one. So we can write u minus 3t equal to what? T square by 2 u minus 1t or ut. So we have seen that u minus 1t equal to what? A step function. Now u minus 2t equal to what? Equal to a ramp function, and u minus 3t equal to a parabolic function. Okay, now in general u minus nt equal to t to the power n minus 1 by n minus 1 factorial u minus 1 t. Okay, now there is another very important properties of these three. The property is, if we differentiate a parabolic function, we will get a ramp function. Now ddt of u minus 3t equal to what? U minus 2t, and ddt of a ramp function gives us a step function. Okay, this is a very important property of these three functions. Okay, now let us conclude for today. The very next day we will cover the impulse function, and sinusoidal function. Okay, so let us conclude for today. Thank you.